As decided, today's live program will be on electromagnetic switch. That means in the commercial market they are named as relay switch. So what are they and how do they operate and how do they work in varieties of systems? We will discuss like that. See, for example, I start with this I keep it here and then make a zoom. You will find it has got 5 terminals, this side 3 and this side 2. We will discuss what are these meant for. So I will test with a power source and using my power source I will show you if I connect my power source voltage is 5, just 5, remember different relays they have got different operating voltage. So what I want to show you, this is the negative terminal of my power source and I will touch it here and you will listen to the sound carefully. It's a very feeble sound, may not be audible because microphone is at a distance. Even though I bring the microphone suppose close to that, you can listen. Hopefully, I hope you are able to listen to the sound of the attraction. It is a make and break mechanism. I just provide you the idea. When I touch, the coil inside gets energized and pulls a iron piece on the top, and that is why a sound is coming. And after some time, I will show you again with another relay. The sound is little higher. For example, this is another electrical operation relay. Of course, this is also electrical operation can be done. But in general, in our mind, these are the robust electromagnetic switches used for operation on various gadgets like your stabilizer, so many things. But basically, I know in our household systems, the stabilizers they do have these components to control the voltage and provide a stable voltage. We will discuss, but first let us listen to the sound as I committed. So for example, I connect one source, suppose I show you, I have connected one point. Who are those points? These green terminals are actually the terminals of the coil. So I have connected already one and the other one I will connect and I will show you or rather help you to listen to the sound carefully and thereafter I will show you what happens next. This requires 12 volt. Remember the other one I was operating Let's see now. This is the front view, and the moment I attach my positive power, you can see the floating terminal comes down, and when there is no power, it goes back. Again I show you. Let me hold it properly so that you can see it comfortably. Coming down when I provide power to the positive terminal. But remember, in the coil there is no positive and there is no negative, but in our DC supply there is a positive and there is a negative. So please observe again, when I do not connect, it goes back to the top terminal, and when I connect my power, it comes down. So who actually attracts? You can see this point where there is a metallic rod, and at a gap there is a plunger, and I give you the idea how is that getting attracted. You can see now. See, this is connected to the rod itself. Again, it goes back. You can see there is a gap now, because at that point there is an iron piece, and below is also an iron rod, and upon that iron rod you can see this white portion of the paper. There is a coil all along the rod. So when the current 6 volt or 12 volt supply goes there, that gets electromagnet, and you know electromagnets are temporary magnets. It is now magnet, but when there is no power, it is not a magnet. So this is the idea we have learned from our school days. Coming down. So that character our engineers have utilized as a switch. How is that a switch? Now the understanding should on start. See, when I provide power, the central terminal is connected down. That means if you provide phase to the central terminal, the phase will be passing to the down point. And if you do not provide power, that will be connected to the off terminal. So there are two connections for the center terminal. One, when there is no power, it is connected to the top terminal. Second, when there is power to the coil, the central terminal connected to the down point, and down point is energized. So like that, these waves, remember, we will discuss more and more, but let it be here first. We will understand what are the different types. I will help you to listen to the sound of that plunger. That's very interesting with the microphone here, very close. This will be easy for me. You just observe carefully. It is there, and when I connect, I do not know. You have to write in the comment box whether you listen to the click sound or not. It is audible to me, and I think it is audible to you through the microphone. That's a good idea. Somebody has mentioned that sound is audible. So this is actually very beautiful, because we never learned these things in our education period. We have missed, and it is our good luck that we see so many things. being experimented in our front. So that's a good idea. Now, after that, I come to one more discussion. What is this? Let's remove this and I show you again another. What is another? It is written there. You can verify this is written for 6-volt operation. Now certain relays the company people they make for different operating voltages. So this is 6 volt. This is operation voltage is 12 and some other voltages are also for 24. But 24 is I think the optimum, the last. Beyond 24, I do not know at least. But 24 I know for commercial purposes, it is mentioned here DC 12-volt DC and current is also mentioned. It is mentioned 5 ampere. That means who will carry 5 ampere? It is a big question. Now remember these two wires green I have already connected to the solder. They connect to the coil. So these two which I have in my fingers will be connected to the circuit. That means either to transistor point or to the power section. So transistor will provide that 6-volt or 12-volt power to the relay coil and thereafter what is the extra items you have to know. These 1, 2, 3 terminals additional I show you. 2 are already connected with wire and 1 wire soldered comes out just now. So I will do soldering after this program. And in another program, I will conduct again on this topic. I will show you the real operation, how the circuit drives the coil and ultimately 220-volt lamps are being operated using this device. For that you have to connect to 220 supply. So for 220 operation, I show you the idea is like this. Let me use one. This point where my screwdriver is there will be going to phase line, 220 phase. And when phase comes to this point, you can find this red wire is connected to that particular point internally. So when you connect phase here, that means suppose my screwdriver is phase and phase comes here, that means phase comes to through this red wire to the central terminal, this particular brass sheet or copper sheet. They have provided copper sheet. That means 5 ampere current will be flowing through this copper sheet. And again, where they go? Sometimes the current will go through this way. And let me show you out externally this point is connected to this wire. You see this wire already I have connected a red wire. So that means current will flow through this red wire to a device, to a lamp, to a fan, to refrigerator, whatever you control will be passing through this line. And when there is no power to the relay coil, the plunger will be coming to the bottom terminal and bottom terminal is here. So current will be flowing through this terminal and to the gadget. That means this particular relay is given a name single pole double throw. That means one pole two-way switch. The single pole two-way switch is the name of this particular electromagnetic switch. Why two-way? I told you During on, it will come to down point and the down gadget will be operated, and during its off, the upper point will be energized and the gadget coming to the upper point will be energized. So, two things will happen at the same time. Suppose you want to make a light flash on and off. So, this process you can follow. So, there will be two lamps, that means one lamp will be controlled by this wire and another lamp will be controlled by this wire. So, this lamp when on, this will be off, and when this will be on, this will be off. So, like that this relay operates. Now, basically these are all 5 ampere relays, but in heavy duty stabilizers, if you open by any way, suppose for any reason, you will observe there are heavy duty relay, that means 30 ampere, 40 ampere, and these wires will be very thicker. This is little thin wire, but coil is very fine wire, copper wire. So they are designed to withstand some milliampere current. Remember, that means suppose you are operating this relay using your power source. Suppose I operate it, you again observe when I make it on, this operates, but by that time this operates, this wire in the coil will be conducting maximum to maximum 1 ampere, but in standard 500 to 700 milliampere, suppose. So this is the condition, and thereafter I will show you, or if necessary I will measure the current also for you if you allow me. I was not prepared. I will bring the multimeter and I will show you what current is flowing through that relay. Now this is the backside operation. When this is down, you can see this is down. This particular spring which is there below has moved a little bit this way. So when you switch it off, that relay switch will be cut off because of the spring. You remember. You see the behavior of the spring now. It has brought this down, this one going up. That means spring is contracting. So I must show you again how is the beauty of the relay switch spring is very important. You can see again this side, the metallic portion goes up and then comes down, goes up, comes down, and this is because of the spring. You can see the spring also expands and contracts. This is very important for all of us to enjoy the beauty of the design. I wanted to see and show the details. So you please have some questions ready by this time for this particular relay, and let me bring my multimeter so that I can show you what amount of current is passing through that particular relay coil. I am ready with my multimeter and I will show you. This is very interesting because whatever we suppose tell is not required. Remember this multimeter use also very important. One is V ohm point, that is red, another is common, and another two terminals are left behind for connection. This is milliampere and microampere, one probe, one particular socket, and another socket is ampere. I don't know. So let us put this red one This red one should be opened from this point and should be connected to the ampere point. Because I do not know exactly what current is flowing, so I cannot put in the milliampere socket because the damage multimeter may be damaged. So, what I want to show you now, I will operate, and so what ampere means, we have to provide here. Remember this is the proper arrangement, and it is written DCA. That means we have to focus what is DC ampere flowing through. So, what I am doing, I am connecting in the background and you just see the meter. What value it will show, let us observe carefully. And how do you connect? Remember, the positive of the source will be going to the positive of the meter like this, and thereafter the current will be flowing through the coil, and then it will be coming to the negative. So, what I am doing, you just observe. This is also important because measurement is important. So, how I connect, you observe. The negative terminal is connected first, suppose, to the coil, and then current comes here. So, this terminal again negative, and I connect. Let us see, it is getting sound. I must show you, listen, help you listen. And remember, this reading comes 0.064. That means it is very less current truly flowing through. So, we can, I think we can utilize this milliampere so that it will be better for us to have a direct idea. Let me show you again. Milliampere means point should be here. Remember DC milliampere, and let me connect the point. This is the point I must connect in green. This is coming 64.7 milliampere only. I was telling 500 to 700 milliampere maximum, those heavy duty relays. So, this relay is just consuming 64 milliampere. This is beautiful. Again, we must confirm 64 milliampere. This way a little bit, 64 milliampere. So, this is very interesting, and I must show you the other relay which is used for motherboard purposes. On computers and televisions and all electronic gadgets, these relays are used. Out of these three, remember I show my test screwdriver. These two, side 1, side 2, they go to the coil. I show you again. These two go to the coil. This is input phase. Suppose you are controlling 5 ampere current to 20 volt. So, the phase will be coming here. I must show you in a proper manner. Phase will be coming here, and then these are the two ways, either this way or this way current will flow. So, sometimes confusing, even I confused during my initial days, how a 220 volt point they have kept near to the coil point. It is for their convenience only they have designed. So this is the input. Remember, this is the input, 220 volt, and that port, that 220 volt will be passing either through this terminal or through this terminal during operation, and these 2 points will be going to the coil terminal, 5 volt operation. Remember, all circuit relays, they are either 5 volt or 12 volt. This is 5 volt operation. You might see also that this design is for 7 ampere, to 50 volt, and ultimately you will find this side it is written 5 volt. So this is for operation in 5 volt situation. Now what I have already shown you, let me put all together here. This is 6 volt relay, the same connection. These two will be passing to the coil, This is phase input, and one way, another way. So this is the idea, and this one already opened by me for your observation, final round. The central terminal will be carrying the 220 volt current either this way or the down way, and this is the wire carrying 5 ampere current, and coil will be carrying 6 volt or 12 volt, but current is 64 milliampere we counted here, and in extreme case it will be 500 milliampere. So with that I come to the end of this program, and I do not know whether you have liked it or not. I find Utkal is there, one of our fan. He observes everything in detail. So thank you all. I hope in the next round I will publish again with all connections, because connections require little bit of pre-preparation, 1 hour preparation for me, and thereafter I will show you. So thank you all, those who all viewed, and those who could not view a live program are requested to go through the live program later on. See you next with another round of program.